Hey everybody, and welcome back to semester 2. We're looking at physics. Physics, as you may or may not know, involves a lot of mathematics. So we're going to start off by asking ourselves, what's up with the math? And part of that math that we're really focused on right now is asking about what a system of equations is. You may remember systems of equations from Math 8, Chapter 5, I believe. You dealt with them in terms of what's called equal values method. So ultimately, a set of equations for which a common solution is sought as a system of equations. Okay, you can actually have a lot of equations within there, but one of the main themes with a system is that you need to eliminate variables. Okay, we'll get into that more tomorrow. For right now, we're just going to look at finding graphical solutions, which is a lot easier ultimately. A solution to a system of equations is generally an ordered pair that makes both of those equations two. It's the intersection of two lines. Okay, we're dealing with straight lines that go off forever, and we want to figure out where those two straight lines meet. So here's an example of a system. We want to determine whether they are given 1, 5. Is that a solution to these? And the way you attack this sort of problem is you take 1, 5, the ordered pair 1, 5, x is 1, y is 5 in this case, and you plug it in for x and y in both equations, and you see what happens. So if we substitute into the first equation, I put the 1 in for the x, I put the 5 in for the y. I multiply this out. 5 times 1 gives me 5. Negative 2 times 5 gives me negative 10. And I got 5 minus 10. Well, that is indeed negative 5. Okay, cool. I got to check the other equation, though. So, one of these equations came back as being true. That doesn't tell me anything other than 1, 5 is a solution for the first problem. Okay, for the first part of this system. Now I got to check the other equation within the system. So I'm going to plug in 1 and 5 again. I plug 1 in, I plug 5 in, and I get 3 minus 35. Well, 3 minus 35 is indeed negative 32. Negative 32 is negative 32. So yeah, this totally works as a solution to both equations. Therefore, 1, 5 is a solution to the system. Here's another example. This time I'm using A and B, and A and B work the same as X and Y. The ordered pair here would be A comma B, because it's alphabetical. And we're going to plug in negative 3 wherever we see A and 2 wherever we see B. So I'm going to use the first equation here. I plug on in. Negative 3 plus 2 is indeed negative 1. No worries. I plug into the other equation. Negative 3 times 3 gives me a negative 9. 2 minus 9 is negative 7. Well, negative 7 is not 4. So this is like an absurd thing, and that means that this is not a solution to that equation. That means that negative 3, 2 is not a solution to the system. Okay? If either equation fails with the point, the system is not solved by that point. Okay? When you graph, you generally expect to only have one line of intersection. And if you have just that one line of intersection, then we call it a consistent system. Okay? Most systems of equations are going to have one answer. Okay? Most of the ones that you do. Now, there are other cases that you can come across. We could have a case where there are two parallel lines. Okay? Two lines are going at the same slope, which means that they'll never really meet up as long as there's some sort of offset between them. As long as their intercepts are different. If I have the same slope, I can never catch up to the other line. So we call those an inconsistent system. And there's also systems where the lines coincide. That means the lines are literally the same line. Okay? And And if they're the same line, then they have infinite solutions. So you really have three options here. You got an option where there's 1 point, 2 point, all the points, or none of the points. Okay? 1, none, all. That's it. You can't have a 2-point solution, and really that's because these lines they're straight. They don't wrap around or curve around or do something weird to where they're going to intersect in multiple places. You will encounter equations that do things like that later in life when you get into like integrated 2 and stuff. But for now, we mostly deal with lines that are systems that are lines, okay? So we have one solution, no solution, infinite solutions. That's it. All right, we're going to solve this by graphing here. And ultimately what we got to do is just graph these two lines. So hopefully you remember how to graph things. We got 2y equals negative 3x plus 6 for my first equation. Now, obviously with that 2y, I want to get y by itself because that's not y equals mx plus b. That's not my slope-intercept format. That's some weird sort of line there. And now we got the slope-intercept format. By dividing by 2 gives us a negative 3 halves for x. 6 divided by 2 gives us 3. So we're going to start at 0, 3 there with our first point, the y-intercept. And then we're going to use the slope of negative 3, 2 to find another point and draw a line there. Notice that the line has arrow tips and goes to those 2 points. So now I've got negative 0.5x minus 1. I'm going to turn that into a decimal or fraction really quick. Decimals aren't super easy to do slopes with. So you can see your rise over run a little bit easier there. We got negative 1/2 for our slope. And we're starting at negative 1 on the y-axis. So let's go ahead and use the slope to find other points. And hey, right there, our two lines are meeting up, and that's at the point 4, negative 3. Notice that the answer is an ordered pair. That's something that a lot of people struggle with. When we get to the physics problems, the answers won't always be ordered pairs because usually we're answering a specific question like what time something is. But while we're dealing with just pure mathematics here, you do want to remember that the answer to all the systems of equations that we're going to deal with will be ordered pairs. So we got another one here. We got 2 lines. We're going to go ahead and graph the first one. We're going to do that by moving over the 3x to get to the y equals mx plus b format. And now I've got a slope of 3 and a y-intercept at 0, negative 6. Notice that 0, negative 6 is off this graph, which is kind of bad form. Make sure that you use graphs that are large enough for what you're doing. And you come on up with a few points there, drop a line. Here, we're going to start graphing the other line. We got negative 2x minus 1. And immediately I see the overlap there at 1, negative 3. All right, another problem. Y plus 2x is 5. So I'm going to move that into slope-intercept form. I do that by moving the 2x over. And I got a slope of negative 2. I got a y-intercept at 0, 5. So I'm going to put my y-intercept. I'm going to use my slope to find some more line points. Drop a line. I got to do some manipulation to the other equation as well. I got to move that 5x over. And I got to divide by 2. That's going to give me a fraction for a slope. So the slope is 5 over 2. That's rise over run. And we're going to start at 0, 5 as well. Hey, look at that. We're starting at 0, 5. That's cool. So I already know what that line is. I got the answer immediately to the system. Because they have the exact same intercept. That's handy. Really easy to solve systems of equations that have the same intercept. All right, another one here. We got Y, you got X has got a decimal on it again, so I'm going to convert that decimal after I move it over and make that into a half X so I can see the slope more easily. Intercept at 0, 1. And I got rise of 1 over run of 2. So graph a few points there, drop a line. Here I need to divide by that 3. It goes in evenly. There's no messy fractions this time. And I got y equals 2x minus 2. You divide both terms by the 3. Make sure you're dividing everything in the equation by the 3. If you do something to one part of an equation, you got to do it to all the parts. Otherwise, it doesn't work quite right. And then you start drawing that line, and really quickly you realize that they meet right there at 2, 2. All right, hopefully this stuff makes sense to you. Graphing should hopefully be a review. Even if systems are new as a concept, graphing 2 lines on a graph shouldn't be all that difficult for you. And it's an easy way to solve a system of equations here. So hopefully this all makes sense and you can rock through these examples and all the stuff we're going to be doing in class tomorrow. So have a great night, and I'll see you in class tomorrow.